And we are live. Welcome, everyone. My name is Daniel, and I will be the host of this session. We are Tech Excellence. I would say, let's get started. Our vision is to raise the bar of technical excellence across the world. Here are our organizers. First and foremost, Valentina Cupac, our founder. Next to her, Alina Liburkina, another co-organizer. Next to her, we have Oliver Ziller, another co-organizer who is also here today. And last but not least, Daniel Moka, who is me. Yeah, here are our speakers from the past. They are all recorded and can be found on YouTube. I recommend everyone to check them out. They're really exciting sessions with broad topics. And here you can already see some people who are here and also in the future. And here also for 2024, we already planned a lot of exciting sessions, so stay tuned. Yeah, of course, online we can be found. You can follow techexcellence.io, or main website, and you can follow us on Meetup, YouTube, LinkedIn, Twitter, or the new name X, GitHub, and we have also Discord community. Feel free to join if you want to talk about technical excellence and software crafting. Huge thanks to our sponsor, Optivem, and to our partner, QE Unit. Yeah, Tech Excellence, learn how to deliver quality software faster. Yeah, let me introduce the speakers of today. We have two people, a duo, let's call it like that. So first of all, Emmanuel, Valverde, Ramos, and we have Marabesi, Matheus. Just a few sentences about them. Emmanuel is a software craftsman, started his career in 2012. He has extensive experience in consulting, product companies, and startups, and he's also passionate about promoting good software practices and extreme programming. Currently works as a senior craftsman at Codurance. Next to him, we have Matheus, who is an aspiring researcher focused on software testing and gamification. Currently, he also working at Codurance, so they work at the same place. And he's an IoT specialist and a big fan of playing with Raspberry Pis. Exciting stuff. So, and the topic of today, the title of the session they're gonna present is a TDD anti-patterns. It sounds really exciting. Before we get into it and before I hand over the microphone, I would like to remind you that if you have any questions about TDD or about the things they present, then feel free to, and don't hesitate to post your questions in the YouTube chat section. And at the end, we are going to dedicate half an hour to address your questions, and Emmanuel and Matheus will answer to them. So, Emmanuel, Matheus, welcome. It's a huge pleasure to have you. I would say the microphone is yours, and I wish you good luck.
Thank you, Daniel. Thank you, everyone, for being here today. We know it's a difficult time, so we really appreciate the support, and also for the people watching afterwards. Thank you as well. Today, we are going to talk about TDD anti-patterns, and we are going to put the focus on test smells. And the agenda for today is basically a small introduction. We are going to talk about a survey that Matheus and myself have been running for the past 2 years. And then we are going to focus on the 5 anti-patterns that we think are more important, or at least more well known: the excessive setup, the mockery, the liar, the hidden dependency, and the giant. And last but not least, we will have some conclusions that we've reached after studying these anti-patterns and these test smells. And from now, let's start with the presentation. Let's start by setting a common ground of understanding so that everyone here understands the same thing and what we expect to learn today in today's session. In today's session, if you are a TDD practitioner, or even if you do test last, you maybe have experienced the idea of having the test as first element of your application, or first class of your application, because they somehow reveal how you use your application, how you communicate, how the classes relate to each other, and so on. So you can somehow have experience that the test somehow talk to you, like tell you more or less how your code is, how it's related. And today we would like to put the focus not on the code smells, but on the test smells. Most of the people are really familiar with the concept of code smell and the factors related to it, but not too many are really familiar with the test smells and how to solve them. So today's session is really about that. before starting, we need to set up a common ground and a real understanding of what a good test is. And thanks to Ken Beck, that bring us this like a few years back, he mentioned this guidance, sort of saying the test desiderata. And in this test desiderata, he basically said that tests should be somehow isolated. They shouldn't fail. They shouldn't change regardless on the order that they run, and they should be independent of each other. They somehow could be composable because the test should be able to uh, have based on the setup like different output in the summary. They should be deterministic. So if nothing changes, nothing should change. They should be fast. They should be easy to write because remember the idea here is to get a short feedback loop and really understand if we are facing a problem. They have to somehow be readable because everything in code is about change. The change is the only motto that we follow in this industry, and is one of the reasons because we mentioned we change the name of the variables, we do refactors. I mean, a variable can be named X and the computer would understand, but the reason because we don't call it X is because we need to read it afterwards and really understand it. So readable is one of the principles that we want to have in our test. We really want to somehow see it, read it, and understand it easily. The test somehow should really test the behavior, and then they shouldn't be somehow tied to the structure of the code. I guess that all of us here agree that tests should be automatized. We don't want to really run the test manually, so that's something important as well. They have to be specific, which basically means that they should fail for an obvious reason, and if possible, for only one reason. That's something that I like to add to that point. They have to be predictable because if a test is flaky, it fails from time to time, you're not going to trust your test. And obviously, if you have a test in which you cannot trust, you're not going to feel secure. And the idea behind doing automated tests is also to have a safety net that helps you whenever you change something. And also for me, the important part and the important point is inspiring because if I have to write tests that are not readable, that are not predictable, that are not specific, I will most likely not be inspired to do it because I see them as a pain and I wouldn't like to do it. That's one of the reasons because today's session makes sense for us. And today we're going to talk about also, like we mentioned, the test anti-patterns. Today we are going to follow the James Carr taxonomy of anti-patterns, which is basically this one. We choose it because it's the more granular, or we think it's the more granular. It has a lot of them in different scenarios. I'm not going to go over them because, as we mentioned, we are only going to put focus on the 5 more important. We discover, or we think that these are the 5 more important because, as I mentioned before, we've been running a survey in the past years, and this is the result of the survey that we've been running. And now I think I pass the mic to Matheus.
Yeah, thanks, Manu. Just also to reinforce this, the James Carr taxonomy. This is also if we search on the internet, we also see like different people adding or removing, let's say, the anti-patterns from list, right? So this is for us, as you mentioned, is a let's say source of truth for this talk. Okay, so let's get started then. Well, we know that TDD is also a polemic subject, right? And then we see a lot of talks around TDD, and even in the tech excellence, people discuss a lot about different aspects of TDD. And then here, I would like to highlight those 4, let's say, points or bullet points that we understand are the reason behind this, why this is a polemic subject. So the first one is when we first try out TDD, or people that try out TDD, they like experience of trying or of the practice, right? It's not like common. It's not easy. At least for me, it wasn't easy to get started testing the writing the test first, and then the production code afterwards. So it's like, how can I test if I don't know the question of existence, right? And this is a fact, right? So this happens with people that is starting and learning new stuff. It's not just TDD, but technical things in general. So this is a fact, right? The second point is that TDD also we can I believe I can say we that TDD if you produce code with TDD it leads with few defects, right? This is a polemic affirmation, let's say, but this we can say at least on some of the studies that you can see in the last 10 to 15 years that it does lead to fewer defects in comparison with code not written with test first. And also we have this debate or arguments that TDD might decrease productivity. Well, there are some supports. So in the same sense that we know that TDD produce code with less defects. Of course, it depends on the context, but in general, we can assume that. On the same line, the same proportion, as the bugs decreases, the time to write the code takes longer. Let's say to finish, if we measure what we are talking about as a task, and if we have a look at the measurement from start to end in minutes, hours, or I don't know, some measurement time, right? For this specific time, we can say that it will lead to take longer. And then, not the least, let's say, but it's a really polemic, and it's been for I don't know how many years, but it's been a while, 2006, 2007, I guess, that the old mantra like TDD is dead, right? By the title itself is a polemic subject, saying like the TDD is dead, but long-live testing, right? More recently, Kent Beck, he has a newsletter that he states that TDD is the ways of testing, because there are some arguments, right? You see some blog posts that says that TDD is not for testing, it's more a design technique. And then you have like such discussions that is on that end. But lately he stated that is a testing tool, right? So those are the four. I think if we start to talk, we will find loads more. But in a nutshell, those are what we found out that are like a polemic subject, right? But then you might see, you might ask, well, okay, so I understand why this is a polemic subject, right? So why you're talking to me, right? Why this is important, and why is this the polemic all about? So well, based on that, on this polemic and everything that we are discussing, there are some reasons that developers they tend to drop TDD or not follow strictly the red green refactor step, right? And the first reasons are not good first contact with TDD, or have not tried yet because of reasons, right? The project, or not having time, or not the space. One that is close to me, I would say, is also the difficulty of adopting TDD on legacy code bases. I think here we also have a talk around this subject. The learning curve. So as we mentioned, why this is polemic, right? Because it requires experience and so on. So this is one of the reasons that developers tend to drop the learning curve or not seeing much benefit. And last but not least, there is some relationship between the tests, cases, or the experience, or everything mixed with resulting with test cases that take longer to run than expected, right? Or when the test is difficult to set up, or when the feedback is not helpful, right? So to that extent, so we are focusing in this talk, or we are seeing this subject, and here we are focusing on in this specific part, right? the test cases that take longer than expected to run, and the pain that we might face when adopting or dropping TDD practice. So let's dive a little bit more on those subjects. So as Manu said, we conducted a survey in 2022, and hopefully we also try to get some data around this year yet. It's like almost Christmas, but we hopefully will get some data on that. And in 2021, we found out that 40% of people learned TDD at work, right? So this was like a small sample. Actually, it was 25 to 30 people that answered the survey, but this gives us a little bit of an idea of the reasons, so we can try to trace back why the TDD is polemic, and then why people start to dropping TDD, resulting on those, let's say, testimonials, right? But in 2022, we also keep, like, we saw the trend keep it going, like, and this sample was much bigger. So in 2022, we had 145, 50 people answer the survey, and still they are learning TDD at work, right? In 21, when we try to inspect more this question, okay, so you learn about TDD at work, but what else you do? Like, you learn by yourself as well, or how are the things, right? And we found that 86% of people that answered the survey learn TDD beyond, like, apart from the company. They also learn by themselves, like through books, video courses, YouTube videos, and different ways of consuming this content, right? At least for me, this number is really expressive, to be honest. In 2022, the same trend, but well, with more people involved, the sample is much bigger. The trend is positive, but it dropped a little bit, but it still is a high number. It's 72% that keeps learning TDD on their own in different contexts, right? So we know that then people are learning TDD at work by themselves. And what about the companies, right? Because we are stating, like, the less defects because it's a polemic subject. So in 2022, we found out, like, 54% of companies that the people answered argue that TDD requires more time to complete a task, right? We can have a discussion here. We can have, like, a lot of arguments and so on and so forth, but kind of that I agree, like, in the sense that I shared early on. If we measure only the time to complete tasks, right, which is actually what interests the most, let's say, companies. And interesting enough, in 2022, this number drops, right? So here we see a drop that the company, that people who answer, they don't complain much about, like, the task being taking longer to complete if we do TDD or if we do not TDD. When I say we, right, the practitioner, the people that write code, right? This is really interesting to see the contrast between year by year, right? And then, given that all the information, we also asked if, well, okay, we have this, we know the companies, we know that they have this perception, or people are learning TDD on not in, like, official manners, right? Not like, let's say, strictly at universities, but by themselves with YouTube courses. And we also wanted to know if the companies that they were working require TDD for them to join, right? Because it's interesting to think about this, let's say, mismatch, let's say, because on 1 year, there is this perception that TDD is a little bit take longer to complete a task. And then here comes the other information that only 18% require TDD actually as part of their hiring process, right? So I think these are some pieces that we can start to think about and as we move forward. This was in 2021, sorry. And in 2022, it even drops, right? So only 14%. So in 2022, we have more companies, more people answer the survey, but we see that less companies are required. Well, the people that answer say that their companies require less, they require TDD to join them. Which is kind of interesting, right? Because we're saying like TDD is a polemic subject. We are saying, well, we also showed some reasons why developers tend to drop TDD. And I think like this is start to depict the picture for us, right? And this is a subject for us because we believe, as we are going to see here, all this combined is what leads the result, let's see, from the of the TDD anti-patterns, let's say, right? All this picture, I would say that what leads to the TDD anti-patterns, right? I don't know if Emmanuel, do you have anything to add on this end? Or if not, we can jump right in.
I would say that I see another interesting topic related to companies being able to train people on TDD, but they don't require any to an entry point, let's say, to access the company or to be hired.
Yeah.
But they in the survey we also have some other details about if they are how they are being trained, right? So like they
Correct.
learn by the book and so on, but there are more interesting information related on the survey. So it's interesting to rephrase it and to review it later on because there are a lot of insights, let's say.
Correct.
All right.
Correct. And this is our reading, just to state here that this is our reading, right? So for some of the things that we are sharing here, we also need to investigate further, right? So I totally agree with what you said. Yep.
And now let's move on to the next slide. And
Start then.
yeah, let's see if I can move on. I don't know why I cannot move. Yeah, there you go.
There you go.
Well, before anything, we would like to do a disclaimer because this presentation has a lot of programming languages. The reason behind it is because we try to find open source projects and real scenarios using these anti-patterns. So we couldn't find only one language for it. And we mentioned this because we also understand that this requires cognitive load and that you may don't understand everything you take a look at. So we'll try to mention everything and try to go on slow paced. But if you need to review it again or ask anything, feel totally free to ask related to the examples or anything.
Yeah, just I would like to also mention that is we are also trying to depict the concepts, right? Because this can fit like basically any programming language of your choice. I think this is also adds like a bit of on the complexity of this subject. But yeah, totally agree with you.
Thank you, Matheus. Okay, we are going to see examples in JavaScript with Jest. We are going to see Nuxt as well, React, also some testing library. We're going to take a look to the JVM with Java and JUnit. We are going to see Kotlin and mockery. We're going to see PHP and PHP unit and Python with MySQL example with PyTest. So bear in mind that you're going to see a lot of languages and keep up with the presentation, please.
Yeah.
Now,
just before, sorry to interrupt, Manu.
Right.
It is also like a disclaimer because those languages, those projects, the code that we are sharing, they are, except one that we can talk about, like they are from open source projects or they were like fetched from production ones. So our code that really people use, right? So is running in production. So just a little disclaimer because this is also important, right? Because it's not like we are mocking stuff out, but it's actually open source projects and code from production systems. Not the real ones, of course, because it's not possible, but with the proper care. Right?
Okay,
So,
thank you,
there
Matheus, for that insight. And let's start by talking about the anti-patterns. Let's first start talking by the excessive setup. Obviously, if you're trying to build a test, one of the things that you first need to start doing is to prepare the state for the test. And that oftentimes needs to have a setup. And whenever that setup is difficult or it gets difficult, it generates also noise. If you want to test something, that test could be failing also for the setup if the setup is big, and it generates noise because it's difficult to take a look at the setup and see where it's failing. And as you may see underneath, you'll see some of the let's say guidance that Ken Beck mentioned before, and how this anti-pattern somehow could impact or violate this guidance. Why? Because the excessive setup may or may not be deterministic. Why? Because if someone touches something from the setup, not even in the test, maybe something you're using, and they touch it, your test may break. It's difficult to write because you need to write the setup, and it probably got bigger, or it can get bigger. It's difficult to read because everything is not on your test. It could be outside your test, and it may not be specific because you now need to take a look into the test and into the setup, and the test could be failing not because of your testing itself, but because of the setup as well. So these are how these test smell relate, or these test anti-pattern relate to the test desiderata we mentioned before. For this example, we're going to go with Nuxt, which is a front-end framework running on Vue, on Overview. And another small disclaimer is that we are going to show production code, as Matheus was saying, and this is not a critic, or we are not trying to judge anything here. We are only stating what we've seen, and we are only doing this to showcase examples of the test anti-patterns. Now, if we take a look at an example of Knox and some of the text that they have, we could see that they have from the first line to the line 13, all of it is just mocking dependencies that this example or this test needs. Obviously, this is kind of difficult to read. You don't know exactly what is mocking, and then not only that, whenever you start the test, you have a before all, which basically will run every time this test is run, and is somehow spying things on JavaScript. For those who are not familiar with JavaScript, they are spying on certain functions, and because of how JavaScript works, they are also mocking the implementation, because JavaScript also calls the real implementation. So they need to also mock it, and it's difficult, or mock it, also give it a behavior, let's say. So you have several things here to difficult the reading, and also that could fail for other reasons, because this could really call the real implementation if you don't do this, and this is difficult. After doing this, is start working on the middlewares, and we have to hide some real code because this setup was bigger and bigger and so on. And then we have the test cases. If you would like to see the real example, you have the link on the top right where it says Nux. That's an example of the real code in itself. But coming to the next example, sorry, uh, you can see a test case. Let's say that we are trying to construct a server with Nux. So the first thing we try to do is we create a context for Nux, then we hide some piece of code because we even have more code. Then we run the server for Nux, and from line 6 to line 12, we are actually don't know what we are testing. It's difficult to read. Is actually trying to talk with test doubles, and is highly complex to understand what it's doing. But it's actually trying to close the server, and then it's trying to regenerate it again. So this test is actually trying to do this, but it's kind of difficult to understand and to highlight exactly what this test is actually trying to do. And this is one of the test anti-patterns. How we could do this in a different way? Okay, maybe not trying to mock this. Maybe this is an acceptance test, and it doesn't have to be that fast. Maybe we are trying to do. We could try to do it in another way. Not try to like mock everything, all the dependencies we have, because it's difficult to know what we are trying to test. People will not be able to follow the test, and we have to be aware at what level are we testing in the testing pyramid, if you're using the testing pyramid, or however you want to call it. But that's important. And now let's move on to another example. This is another example of a real application that basically is used to teach you how to test. So you have it's a text editor. You have your code on one side, the test you wrote on the other side, and this application was built on React. And if we take a look at the test case for this example, you have a wrapper, which basically is a component that takes over 16 dependencies, more or less,
Yep.
to test it. And then this is an example of a test. We're running a test that basically is only trying to see if the editor has some parameter on it. And to do that, we are basically trying to pass all the arguments as null because we don't care about them for this test. Then we are passing some arguments to it. In line 6, we can see that we are passing an argument that is read only to true. For some reason that is not described on the test, in line 8, we're passing an empty object. We don't know why. And then if we see the line 14 to 15, we are only testing that the prop that we share on line 6 is there. So how could we somehow do this differently? We could somehow, first of all, compose the components we want to build better. So if we have the code editor and then we have the text editor, the test editor on one side and then in the other one, this test may doesn't make sense. Obviously, using things like builders and other patterns that could really help us build this component better could also help. And these are two ways of solving this issue. Other things could be, in this case, no, but maybe using fixtures and things like that, but using it properly and with care. And now let's move on to Jenkins. Maybe some of you use Jenkins at your work or even in your personal projects if you're using it. Today we're going to see an example, a small example. This is Java using JUnit. And basically, we are creating a test that somehow is trying to assert that whenever you go into localhost with your or you're running your server on localhost, let's say, you will see a warning. And the first thing that strikes me is in line 5, we have a throw exception that basically is stating that this test somehow could throw an exception. But what does it mean? Why? And an exception, and what kind of exception it is? We start by having a difficult reading of the same test. And then from line 6 to line 8, we have that we create a web client to test something from so to test the server, we are creating a web client that is getting the information from a configuration, and then we are adding to that configuration the local host URL. And then after all this setup that is happening under the scenes, because we are not taking a look at what's really doing the web client, and we are not testing that part, I guess that's where probably the exceptions come from. We are asserting that the HTML of the website has this message. Obviously, this is kind of not only difficult to read, difficult to set up, and we need to know why we are doing the web client part. Honestly, to do this better, again, it's the same example as before. If we are trying to test a server, maybe it makes sense to not have it connected to something. We could use certain test doubles in this case or at least create a web client that we know is not going to fail, or maybe do some other assertions over the code and over the HTML instead of like having it to like render everything. But that's another possible solution for this example. And now let's move on to the next anti-pattern, the mockery. The mockery is an interesting one. Mocking is good. Using test double is actually great, and it helps us quite a lot to isolate our dependencies and use them with care and test what we are actually trying to test. But oftentimes, the problem I see is that developers use mock or the term mock for everything. Mock is not only used for mocks, it's used for fakes, for stubs, and for spies as well, and many other test doubles. And the idea here is that you don't have to use them for all, because if you use it that way, you're probably not being deterministic. You could be testing the structure of the code and not the behavior in itself, as I mentioned before on the test desiderata. And it could be difficult to read for another developer that identifies the test doubles and knows what they are, because you have to pay too much attention to what type of test doubles people are using. And obviously, we can move on to see a real example. This is an example on Kotlin with mockery, and this is the production code. We have a payment service that basically takes two isolated dependencies, which is a repository and a payment gateway. And then we have somehow a process method that takes a user and payment details and returns a boolean somehow. Um, as you may see here, the repository is testing that if the user exists, and then is calling the payment gateway with the payment details and is returning whatever the payment gateway returns. Obviously, we could inverse this if we want to and so on. But the important part here for me is what is really happening on line 11. We are returning whatever the payment gateway service is providing us. And if not, obviously, we are returning false. If we take a look to the test for this, this is a test that should be successful. The first thing we do is isolate the dependencies by using test doubles, in this case, mocks. Then we call the payment service with, we pass the arguments to fulfill the contract. And then we have a test for a successful payment. In this test case, we have a setup in which we create a user. Then on line 12, we have a repository. We are saying that whenever a repository is being called with anything, we will return true because we don't want to get stuck there. And then on line 13, we are having a call that says that whenever the payment gateway pay with anything, will return true. And after that, we are asserting on line 15 the payment process with the user and payment details. The catch here, or the problem that we can see here, is we are actually not asserting anything because we are telling our test double to return as true, and we are asserting true. So this is like assert true equals true. Yeah, it's the same. So nothing to test here. This test is actually not testing anything, and this is one of the most common examples of how to not use test doubles correctly. And now let's move on. This is the implementation, and here's the line that is important for us. Obviously, if we didn't have this line, we could do it some other way. But how should it be? Right? I mean, now let's put the focus on how it should be. We should verify that user repository has been called with the user we've created, because that's the idea. We pass you a user. We really want to know that that user has been got into the repository. And then we also want to know that the payment gateway has been called because it's a side effect. It's something that has to happen in the background. We are not trying to assert that the payment gateway is returning something. We are trying to assert that the payment gateway has been called, which is actually the value of this test, not the other one. And if you're interested into learning more about test doubles and so on, Uncle Bob has a great blog post from 2014 talking about test doubles. But if you have read the book X Unit from 2006, they also mention this. If you're interested in to take a look to them. But if not, we are going to make a small introduction into them. Let's talk about test doubles in itself. Let's talk about first dummies. Dummies are objects that only needs to complete are only used to complete parameter list and fulfill the contract that we have between classes. They are not meant to be used. They are meant to fulfill contracts we have. And then we have stubs, which is the opposite to the dummy because we want to do something with them. And what we want is whenever we are calling something from the stub, we are actually expecting to receive what we are telling the stub to give us. So that's the idea behind the stub. The spies are also called poor man mocks, which basically means that they are only asserting if you are calling with some arguments and also you can ask at what time they have been called and so on. The idea is to spy the behavior, not to test the actual output. And then we have mocks that mocks the setup, and they have expectations on what to receive, and also they could throw exception depending on the testing library if they are not being called or they have not been called with what you expected. And last but not least, we have fakes, which basically are objects that could be handmade, like the stubs, and they could have some business logic, and they are also well known as poor men stubs. So if you are interested in to know more about this terminology, you could Google it.
Yeah, but sorry, Manu, just
Yeah.
to share something. Basically, well, in the previous example, we just use a true mock, right? We just replace
Yep.
the way that it was with a true mock. So that's for example, that could be say a quick example that I can rely on. So yeah,
Yeah.
this is a
Thank you.
nice catch. Yeah,
Thank you,
no,
Matheus. And not just that, thank you because you also give me the pass for the next slide. We're going to talk about stubs and PHP. For those that are not familiar with PHP, this is an example in PHP using PHP unit. So the creation of the stubs is going to be using PHP unit. If you have been doing it with mockery or prophecy, it's different. So be aware of it. Now, we are here trying to create, let's say, a release from a repository, and the idea here is to identify the files that need to be that has changed and that are going to be in the new release. So this PHP code is actually trying to test that if you don't pass any files for the release, you get an exception, which is exactly what we stated on line 3. And then for some reason, we are creating stubs for the file repository and the file to be released repository. And then we ensemble everything with the version, the file repository, the branch that we want to do it. And last but not least, we actually do the final release. This obviously throws an exception, but there is a catch here. We have been creating things in line 5 and line 6, but they are not being used anywhere. So maybe they are dummies and they are not stubs. This is an example on when to use dummies. We are not doing anything with them. We are only passing them to fulfill the new assemble, let's say, contract that we have because they are collaborators for that class. So we could create dummies for them and not stubs. We don't expect anything from them. This is an example of a better use of the stubs. Is from the same concept, or at least domain, so of saying. We are trying to generate a new release, and what we are doing is we have a file. We create a stub for the file repository, and whenever we call the method find file, we will return the file we created before. So whenever we go into the main branch and get everything at the end, in line 14, you can see how the file is being used. Also, there is another smell here, but we can talk about that later on the conclusions if you want. And this is important, I guess. Remember that if you are using mockery on Java or even in other languages, in other programming languages, you are not doing the anti-pattern mockery. And we mentioned this because there is a Stack Overflow thread that really mentioned this. And actually, it reminds me to one important topic here. This is also a way of understanding that people may have misunderstood some of the things we mentioned. And this is one of the key topics that Matheus mentioned in the introduction. When we talk about, for instance, people that do outside in or know about TD styles, they tend to think that outside in it goes from mocking everything and isolating things, and that's not exactly true. That's a misconception, and we think it's actually related to this example and this topic, and all things that could lead to this mockery problem or this anti-pattern concretely is to not have experience with TDD or having not enough experience doing TDD and working with collaborators. Another thing we think is really important and that could lead us to this kind of anti-pattern is not having doing TD and do test last. Why? Because if we remember how everyone learns to code, you learn by doing first. You learn how to write variables, then you learn how to do your conditionals, then your loops, then object-oriented programming, then patterns, and at some point on your learning curve, you learn how to test, but you don't know how to test properly because no one tends to teach you how to test properly. And then you have some misconceptions, and then you start reading books and start reading things, and then everything gets out of control. That's one of the reasons why we think the mockery is also misunderstood. And now let's talk about another thing. If you are part of this meetup, you may have seen this other video talking about test doubles from Marcelo Chiriadaya. I'm sorry if I misspelled your name. I didn't mean to. But we think it's really interesting because he has an hour and a half video explaining how to use test doubles. So if you're interested in to know more about it, just go and look at the video later on. You really love it. I really like it quite a lot. So, and I don't know if you want to add something, Matheus.
Yeah, I think that he also really goes to the point, like showing the pros and cons about using test doubles, actually,
Correct.
in specific how you design and so on and so forth. So I think it's really helpful to go there and see how he tends to favor fakes, actually, instead of more fakes over the other test doubles. But yeah, that's it.
Correct. Now I give you the mic, Matheus.
Let's go then. So the next one is a famous one. This is the most famous, I guess, that we have faced while we were working with Jest, at least the liar, because it relates with Node and is a classic, right? Because when you have, like, you see when you join well, at least the classic scenario is, for me, is when you join a project and then you see, whoa, this project has tests, right? So, whoa, awesome. And then when you start to work and then we start to see the code base, you start to notice that the tests are like some kind of not giving you confidence. But just once you start to have a look and say, oh, okay, this is missing something important. And in this specific case that we're going to see, that is in JavaScript again, and this is stated on their documentation, but shows how asynchronous code can be a little bit tricky. Because here, what we are doing, we are testing where we're creating a function, a hypothetical function, and then inside this function that is a callback, we assert on the data that we expect to be after the execution, right? So this is simple, a function, and then an assert. It should be fine. The catch here is that we have this callback, and then when we fetch the data, the loop that we have in the test is not. It always pass. So in Node, if you have ever worked with Node and any callback related code, in this specific test, that this block of function is not blocking. So Jest will execute the code, it goes through, and you say ring, okay, right? So you're just happy, and I don't care much about the test anymore. You will just realize this error if you try to force this to be false, or if you change the expected to be true. And how we can provide, like, how we would better test an asynchronous code in Jest in this case. So basically, Jest offers a helper, so just a parameter in your test that gives you the power to tell Jest when the test is done, right? So inside the callback, that's when the action happens. After the assertion, you say, look, Jest, I'm done. So now I want to see the test result, right? So doing this small change will avoid the false positive, or what we are calling here the liar, right? So just assert, done, and that's it. Another important point is to do the same when something bad happens. In this case, because we are using a try and catch scenario, it's also good to do the same when the error happens, right? Otherwise, this specific test will time out, right? So you'll fail for the wrong reason in this specific scenario. This would be an example, a simple example of like overcoming this asynchronous testing code from the liar, right? So if you like JavaScript, so that's it, right? Another classic, another example that I was mentioning is test cases like this, right? So I won't say anything, and I will just give, we have a test, of course, and then we want to update the user, right? And then here we have the body of the test, right? The same here we have with the lead user. So here I expect to be updating the user, right? So I give some parameters, whatever user is, like possibly an entity, or just expect something to be called. And then here is the same, a delete user, right? So I just expect this to do something, right? So here I'll give you, I would like just 5 seconds to realize that that's it, right? So no assertions. So you just have tests that do, like they execute code, but we don't know what to expect from them, right? And that's it. Those of this is the more like explicit one when we say the liar, right? Because actually they are executing the code, and but we don't know explicitly what is the behavior, the intended behavior. So yeah, just watch out for asynchronous code that can happen. This is case in JavaScript, in Node specifically, but it can be in any other asynchronous code that waits some execution to happen in the future, right? Right, the hidden dependency. The hidden dependency is kind of tricky because, at least from our experience, we can experience this in different tastes, right? So this is when your test, you don't know, actually you have to dive into the code to understand why the test is failing, or where is the root cause for your test to be failing, right? So let's see some of the examples that we can share with you today. So this is in Python. So let's pretend that this is our production code, right? So the production code, what it's going to do is this query just supposed to be on the database. So kind of integration test on the repository level, let's say, we can assume. And then we are going to fetch the orders, like if it is a e-commerce or some application that is selling something, we go over there, fetch the orders that were manually made, and that the test orders. So just for testing purposes, right? So this is our production code. A test, like an integration test in this case, that we can write, or that we saw, is as simple as that, right? So we want to list those orders in a specific criteria. So in Python, we have the DB resources. We define our test that we want to load the products and see the manual ones. The first step for our test is, okay, we're going to fetch the configuration to connect with my database. And besides that, I'm going to parse a CSV with the hard-coded data that I know that's correct. So I can trust myself that this data is correct. The next step that we see in this example is just to create the data source, right? The connection with the database and so on and so forth. We execute the code to go there and fetch the information for us. And then we expect the test is as simple as that, right? We assert that what is in the CSV, that is the hard code value that we assume that is true, is the expected result from the query, the production code, right? So at first glance, this seems to be like a simple test, right? A simple to see, and I do agree with that. The problem is if you're following like a test first approach, so read first. So the first thing here is that when this fails, it's difficult to see where the problem is, right? Because it's a lot of information, maybe from the CSV, from other stuff, but here is polluted. The output of the test is not giving an easy feedback for action, right? So and this is just because we forgot, like in this specific case, after diving into the code, going to the function that we had, going to the query, it was like just this simple fix, right? Just we forgot to add this constraint in the query, and it was fixed. The text was fixed. I think the key message here is for the hidden dependency specifically is to listen to your tests and then try to mitigate if the output is clear. So if you can take action on that.
Also, a good thing could be like the output should be readable. I mean, because remember, they have to be simple to identify and fail for one reason. They have to be specific, and this is also failing in that.
For example, yes. So, and then if you are doing pair or if you're programming, so like there is this debugging path, right? So you start from the service. The service is calling the repository. So you start to debug or what's going on with the repository. I'm 100% sure that it was working. Then you go down to the repository, say, oh, what's going on? This has the connection. And then you go to the database. You say, oh, okay, the database is seems fine. And then you go back and then you start to debug the test, right? So yeah. So thanks for that. Another example here of the hidden dependency that we can share with you today is not related with the database itself, but it can show up in the front end. For instance, this is a view using view and test library. So imagine that we want to write a test that just lists the administrators of a system. So then the end user can select one of those, right? As simple as that. So you say, okay, so the first step that I will do in my test is, of course, write my test and then go to the store. And in this specific case, we are using Vuex. So this is where all the information or the data for this specific application sits. So it's kind of a requirement to use that in this specific context. After that, we render the page. So we have a page that is going to be where the administrator list will show up. As simple as that. We have some other test doubles that we pass in, but they are not doing much. We click on this select box just to see the options, and then we wait for the response, right? So another kind of test that is simple. So even if we haven't worked with Vue, we understand that this is something that we can read and understand without much going to detail. But the big gotcha in this example is in the store, right? So the first question that I would ask myself is, how can I assert this as an admin? Where this is coming from, right? So what is happening? And why I'm saying that? Because if the test, so in this specific example, if the test, you start for the test failing first, it will be difficult to understand where this is coming from, right? So, okay, the test is in red, so where the admin comes from. So if you start to debug again, the flow of debugging, trying to understand the code, you'll find out that the store, the line 2 of the store, is the one that holds this information, right? But given the complexity of the view store or the Vuex or the pattern itself, if we start to dive in, we'll see that this is not easy. So we go to the store, we inspect the store. In this specific case, we are using namespace the store. We see that the name admin is not there. We inspect a little bit more. We see that we have an admin namespace, and then inside this admin namespace, we see that we build the module for this store, right? And then inside this specific case, inside this store, this module is where the admin is at, right? So if you look from the failing test, you're going to downwards, right? Something to avoid that, to try to just tracing to debug, tracing back would be as simple as adding this, for example, hint for whoever is reading the test or whoever is trying to understand the code. Because now, instead of it is being hidden inside the store or away from the test, it is explicit. So you're saying, look, I'm creating this store where the data I trust is at, and I want this to be in the page when I click on this list box, right? So some of the points of attention that we can show here is to use libraries that generate fake data that we saw. Try to test adapters from this, like try to make explicit. It says like adapters as soon as possible, in this case for the Python code, but try to be more explicit on the output, making this like readable and specific. And if possible, avoid external resources on your test. So yeah, so we finally got into the giant, and this one uh, is a classic as well. So the giant is basically an object under test. So you have a class that is under test, and you start to exercise in the same test case different methods of a given class, right? This is why in the definition of this anti-pattern, it states that is usually if you have the giant in your test, is possibly that you might have a god object as well. So in this example, we are going to switch a bit from PHP because we have this really famous project that is used like across the world. And there is one specific test that says test conversion. The first thing that we see here that we can relate with the giant is the for loop, right? So the for loop inside the test, there are some discussions, I guess, around if we should use for or loops or logic inside your tests. But here, let's forget about this for a moment. Here, let's focus on how the test was built, right? So we have a bunch of values or random values here on line 3 to 6. And then over those random values, we want to test out different kind of conversions for those random numbers. Right? So here, the first thing inside the loop that we see, we are trying to convert, I think it's centimeters to WIP. I don't know the specific measurement that this relates to, but is asserting that. Then we also have centimeters to inch on the same loop. We keep going with different kinds of assertions in the same loop. So I just remove like the bit of the code up to fit in the slide, but it keeps going, right? So we are testing different kinds of conversions on the same test. So for example, this test has, let's say, I don't know how many because we didn't count, but this test, so, and this keep going. I'm just keeping going because this is a huge test. That's why we call it the giant. Even though the production code is not the God object, this is a giant test case. But this test case keeps going, and it has many reasons to fail, right? So if one fails, first, it will be difficult to see which one specifically failed because you're going to need to trace down. Also, adding that to, let me see, adding to the equation, we also have, let's see, we also have different kinds of loops. So if one fails, the test is gone, and you don't know if it's just this specific conversion or the change that we did affects all the conversions, right? So because the first one that fails is stopped. Then it's not really readable, right? Because here we are like just going slide by slide, just to see and depict how many different ways this single test case is exercising this piece of code. So ideally, one of the solutions that we can provide is, well, we can use the same test, but then we can move the data, the for loop, for a data provider, for example. Or if you're not comfortable with the data provider, I see no harm in having the test explicit for yourself, like one by one, just exercising the bit that you have. Probably we're going to have, like, I don't know, 15 tests, 20 tests. I don't see much of a problem, but it'll be much more explicit and specific and easy for someone else to read when something goes wrong. You're going to have like a much readable or much easier feedback loop, right? I don't know if you want to add something, Manuel, on this one.
On this one, I would like to add only that all the slides that you've seen before is the same test case. So all these assertions are on the same test. So you have more than 16 because I counted.
16, right?
Yeah. For me, one of the solutions could be, as Matheus was saying, parameterizing tests, even having them together, but also not trying to have like the conversion in line 7 for each of them, because you have like the results, but you have the conversion as well. So it's difficult. If you make a change, the test will fail. You will not know if your conversion on the production code somehow relates to one of the tests, because you can change the unities and so on. So these tests are not really helpful and are a kind of a pain in the ass to maintain, because they will fail once, but you will not know where, why, or if there are other affected, as Matheus was mentioning.
Yeah. Well, let's see. I think that's it that we have.
Let's
So
move on to the conclusions then.
let's see how it goes.
Okay, let's talk about the conclusions we reach after like taking a look at everything we've discussed and so on. Well, whenever one of the first things that I like to say is that whenever you find one of these test smells, you're probably not finding one. You're probably finding more than one. For instance, the example that Matheus was showing about the store is exactly the same example of that you can have seen on when we were talking about Jenkins. No, yeah, Jenkins. When with the web client. Why? Because you have some old dependency there, and we do not know how it behaves, and it could throw exceptions. So it's more or less the same thing. You have to deep dive and see how it's implemented if something goes wrong. And the idea is that you shouldn't have to be spending your time debugging. The test should be as simple as possible, so you don't have to debug also the test, because you are only you are not only trying to get production code ready and do the test that really should help you. You are now having to also debug your test, so now it's a pain in the ass for you.
Yeah, for
And
example.
yeah, and then also other thing that is important to mention is that it's normal to see the patterns in the code base, and the key is how to manage them. So what we mentioned today as somehow how to solve them is an example, but for me, and it's also related to other point here. It depends on each case, because each case has a different context, and related to some other points here is there are no automatic steps to do on these refactors. So, for instance, if you're working on data clamps or you're working on something, you know the refactor on your IDE, and you could do whatever you want, like extract method, extract constant, and so on. But for the test smells, there is nothing. The only thing you can do is pay attention, be aware of it, and also try to listen to your test. So my advice here would be listen to your test, because they actually talk to you and they tell you when something is painful. And this is also linked to the remember part, because this is an iterative process. We write the first test, but we are going to keep writing tests all the time, and the test somehow will talk to us and tell us, hey, something that you're doing is not correct. And also be mindful that even if the tests are in this scenario or in this case or in this state, the idea behind it is that they are also giving you value and giving you support. So treat them well. They still being first users of your application, and try to make them better if you can. And I think that the last point that we haven't mentioned is that, as you have seen some of these anti-patterns and tests as well, they somehow violate the test desiderata on many ways. And because they also concatenate, you can see a lot of smells together. And the idea behind it is to keep track and identify an exercise that I would like to share with you. If you would like to do it, is like go into your production code whenever you're working and try to identify these smells, try to find them and see if they really I mean, I'm sure that if you're working with TD or even with Teslas, you can identify these smells, and because you do the test and you will feel the pain. So try to do the exercise of trying to identify what smell is, to try to identify what refactor to do and how could improve it. That would be my suggestion. I don't know, Matheus.
Yeah. I mean, well, at least I would like to highlight the emphasis on the iterative as you did, and at least from my point of view, when I write code or when I'm testing driving, uh, at least don't fall in the trap that the test should be perfect without anything from the beginning. So just keep like I think the important part here is to always keep iterating over it, but not don't like be blocked by those things that we are highlighting here, right? So as you mentioned, is iteratively. So just iterate, 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 and we have like a wrapping up. There you go.
I would like to mention some quote about Kenbeck. We are not great programmers. We are programmers with good habits. This is a habit we have to cultivate and we have to understand. And the idea behind this session or today's session is basically to identify this code smell, bring everything to you, and try to work on that part. That is not really, let's say, work from the ID perspective or from the professional side perspective. It's not like too much look up to. And obviously, if you could like to know a bit more about this, there are books about this. Like this is a free ebook about common patterns that make TD harder. That has been well, the second version will be launched and is free. So if you want to know more about these anti-patterns and about what we've discussed today, you could find it on the link on the slides. And not just that, if you would like to know more of the other taxonomies, there are other books that talk about the same thing, but taking into consideration different taxonomies and taking into account different smells. Like for instance, one that I like that I would like to dig deeper into is like the general fixture, which is something that I've seen lately on some code bases. So if you're interested into it, remember that you could see the book. And last but not least, if you are interested in to know more about the test desiderata, what it is, and all the examples, Kenbeck has YouTube some YouTube videos talking about it and all the phases. So if you're interested, go into YouTube and take a look. And last but not least, let's move on to the Q&A.
That's it. So thank you very much for the opportunity. We have like here Oliver and Daniel again. So yeah, thank you. And for everyone that is listening to us.
Awesome. Yeah, great job, guys. Really great job. I really liked how you guys associated all the smells with the real life coding examples. We could really feel the pain of them, right? And I think the biggest takeaway, what you also mentioned and brought up, I mean, relating to these tests and tests generally, that yeah, many developers get this wrong. Namely, they think that tests are only used for verification, but they can be excellently and very powerfully used for designing the software, designing our code and tests. And yeah, exactly, they are design tools if they use them for that. So yeah, but you brought this point up. So yeah, great job. Yeah, we have plenty of questions. I would propose let's go through them and let's see what the audience was talking about. Here's the first from Jose. So he asks, where do you set the limit to go from a unit test to an integration test? Should we test the same thing in both, but only changing the mock for the real component?
Would you like to go, Matheus?
As you wish, you can go first. I don't mind. We are going to agree on the answer. That's it.
For me is one thing that is important is I don't like to call integration or unit test. For me is more about the subject under test. So it depends on the subject under test you're testing, where you're putting the focus. You will be doing some kind of test or other kind of test. If I'm testing, let's say front end, right, and I'm talking about a component that is composed by several components, this is my subject under test. So I will not test double the components underneath. I will be testing everything, but everything that is outside that scope, I will probably test double it if needed, because I don't want to work with that part. So for me, it depends on how you use that. Let's say that scoping, right? If you are putting like looking to the small component or to the big component on the application.
Yeah, I think that I would like to add as well that I think the key of the question is should we test the same thing in both but only change the mock? I think that's at least from my point of view, I think that is the heart of the question. And agreeing on what Manu said, I think that we want different feedback loops, right? So for example, depending on the occasion, if I can give an example on an API, for example, if you start from the outside in, if you follow the outside in approach, probably you're going to test starting from the outside, so calling the HTTP method, and then this, how we call, we are going to test the interaction between the controller, then the service, and at some point, you might test the same data set that you have for your service and the one that you have from the integration point of view. If we take this example, I see no problem because here the focus is on the feedback, the kind of feedback that I want. So if I want faster feedback, I go to my service that is testing almost the same, could be the same data set, but I go from there. If I want a feedback, a great, the outermost, like from the call, from the API, I'll go for the integration. I think that's a kind of example in this sense.
I agree on this, and also related to what I was trying to mention about the scoping, it's also a good point. If you're trying to test some side effect, you're probably not going to test if you're doing the outside in, you're probably not going to test it from outside that part because it's not behavioral. It's something that is going to happen. So you are not probably going to enter from the outside. You're probably going to find the spot on the service or more inside, and that's going to be your outside. That's why I was trying to say if you're talking about that and that's your integration test, okay. But for me, again, it's like the subject on the test. Am I trying to test the system or that this system is actually calling another system? And based on that, I'll be doing some kind of test or the other one.
Hope that it was clear.
All right. Yeah, I can agree with that. Thanks a lot. It was a great and extensive answer. Let's jump to the next one from Wolfgang Klinger. He had a point, and I have a question about this. He says, I doubt that these tests were created using TDD, writing tests first. So here is my question. What do you think? Could these tests have been prevented by using TDD? Or
Well,
Now you go.
sure. Yeah, short and sharp. I think so. Yeah, I do agree. I think that's the whole idea behind this topic or the subject that we are talking about goes towards that idea, let's say, because there are some of those that, of course, we also think would not have been possible to write them if you start from the test first. So yeah, I do agree with this sentence.
Um, yeah, most likely align. I agree, and I think that's why we are doing these surveys and why we are studying this part, because at least from the community part, there are people that don't see value in it, and we've seen other studies that people are not doing TDD and they don't see value in it, and it's really a part of trying to understand that because then we see the outcome of it and these examples, and then we start talking about but that doesn't make sense, and then it's really being painful. Are we really? I mean, they may don't feel the pain, and maybe it works for them, which is all right, but I guess that with TD you could have prevented, but the idea is also that we don't have the context of each of these projects, so we shouldn't be like thinking too much about it. More on the if we could have prevented, maybe we could, but we maybe they don't know how to do TD, or maybe they didn't have the space. So that's also important to understand.
Yeah, for
absolutely.
example, yeah, just to complement, because for example, the last example in PHP, I give myself the doubt that it was possible to write that kind of test following TDD. Like even though that is inside the loop, I think it would be an example that could be possible, just like what Manu mentioned.
And also related to what Matheus was saying, most of the one of the I think one of the misconceptions that why people talk about the different schools of TDD and also the anti-pattern of the mockist and of the mockery. I think that is somehow also related with something that is more related to people doing TDD the wrong way.
Mhm.
So I think that some of the anti-patterns are related to how you learn and at what level on your career you are. Because whenever you learn TD, depending on how you are, you could learn by doing inside out because you learn by doing functions. Then you start working with object-oriented programming. Then you work with collaborators. Then you start working with test doubles. And then from that part, you move to outside in and so on. If you follow that path, you're probably if you're doing TD at your work and you are not getting into, let's say, the outside in yet, you're most likely to generate those tests probably. So I see that is somehow related, and that's why we in the survey we ask where do you learn and how do you learn. because we wanted to know that part, but to know exactly how are you doing it, so we can somehow identify and relate them.
True, good points. And I think we also need to mention that so TDD, I mean, practicing TDD does not automatically lead to good design, right? I mean, we are the one who makes the decisions. We have to know these code smells, and if we don't know them, we can still make these with TDD. Actually, a lot of people are complaining about TDD. Hey, it doesn't work. I have a lot of bad tests, and it's a burden for us. But actually, of course, they didn't follow these practices, what you just presented. So yeah, exactly. Yeah, good point.
Interesting
Have
point
you
there.
actually? Sorry, I go on. You.
No, I was just about to say that an interesting point there is that actually you're putting the responsibility on the practice and not on you. That's for me the key aspect there. You're putting the
Bang on.
responsibility outside, not inside. But anyway,
Bang on.
Have you actually seen a company that trains their developers in TDD, like having a course, workshops that they do, and they actually want them to afterwards do TDD?
go Matheus if you want to.
Yeah. Well, yes, we both, at least, we work. We can say that we work at Coduris. You mentioned in the link. So, for Coduris is an example, actually. That there is a program as well for who is starting that they learn TDD across like their journey.
Yeah.
We also, at least, I also see that we ourselves sometimes we even go to help other companies on their journey to learn TDE, so we give a hand as well. But now that you asked me, I can relate on my personal experience that before it was difficult to see like companies actually teaching developers on doing TDD. Right, so it was not like, okay, we are going to teach you actually do how to do TDD.
And they see a return on investment. What would you say?
I would say yes. My personal opinion here, obviously, as Matheus was mentioning, we do it inside. We have the academy program, so if you're like joining the sector and you have some experience, then you can join the academy. And then we don't look for your practices; we look for your attitude, and then we teach you how to do everything else. Because the attitude is what matters. The practices come along because it's just teaching you how to do it. And if we know how to do it, it's easy to do it. So that's an example, but we've also seen it in other places, not only in Cojudens, and also we do it in the communities. Like for instance, I like to do it in the community I used to I used to be part of, and I think that that's part of giving back what we know, not only from the side of the companies, but also from our side as well as individuals.
Yeah, just to let's say amend on that, I do see usually I see that they see the benefit, but it's a process, right? So you have to. It's not like okay, oh, I see, this is good. No, there is like it's a process, right? So first you need to start the process and show the benefits, and then the pros, the cons, and then later on in the process is when the benefits of the practice start to pop up, right? Because it's less time focusing, let's say, in fixing or firefighting things, and then starts to think about how to build the things and how to move forward.
Actually, an interesting point there is that you mentioned is like not exactly talking about the benefits of doing it, and not even the practice in itself. It's like highlighting the errors, like the problems that they having. Okay, we're having problems here. Okay, how could we solve them? Because that's the problem, right? So how could we solve them? If you spot that on, and then you like keep pushing, but slightly, and knowing when to push and when not to push, and then having the experience to like really move that forward, because you need the experience to move it forward, then it works. But again, that also takes experience from the side of the person or the people moving this. So I see the button there.
And quite some trust from the company.
But you have to build the trust as well. I mean, that's something that sometimes is not given, right?
Need to build it up. Thank you.
You're welcome.
All right. Nice discussion. Let's jump to the next question from Facundo. He asks, what is the difference between spies and true mocks? Maybe could you please explain it again, and maybe in a different way, so it is more understandable for everyone?
You want to go, Matheus?
Yeah, I mean the key difference, at least what I understand as a spy and true mocks, is that like the spies usually they don't change the original test code. Usually they don't. You just listen to if it was called or not, or if it was made, and then the true mocks is actually you don't rely on the implementation of them. You just go and then mock everything else, right? So you expect the behavior, right? So expect the behavior, something to do. So on the test, on the test level, I think that is one. I would be interested in the spies, for example. I would be interested only if something happened, an interaction happened, and on the true mocks, I would be interested on the behavior. If something was called with the specific thing that I'm waiting that to be called. I think that's what I think that's what would be something. I don't know, Manu.
I was
maybe?
about to explain it like simpler in like
In
I
a
think
different-
in a different way to try to like simplify maybe. Let's say that we want to test leaves of our code, right? So we are trying to test some part of an if statement of our code. I may use a mock for getting inside that leaf, and whether if what I really want to do is to test if something and something from outside has been called, or if something had been called or had happened somehow, I may use a spy. This is more or less how I try to see it. If I need to navigate through leaves, I tend to use more mocks, and if I try to only assert if something had happened, I use spies. So I tend to think that way.
Good one.
Yep, great.
Hopefully,
one.
it was more clear. Yeah.
But again,
Yeah.
if you like, you can see the YouTube video that Tech Excellence had that we mentioned before,
Yeah.
and they also get into too much depth.
Yeah, that's excellent resource. Thanks for mentioning. Appreciate. Yeah, great. We still have time for questions. Let's go for the next one. From
Wow, a lot of questions. Wow.
yeah, cool. Yeah, people are really interested. It was a great session. It shows. Katan, one of the most common reasons I've seen teams rejecting testing is the pain of creating and or running them. Any advice for these teams?
I guess that for me the question is it more painful to do it manually, or is it more painful to do it automatically and run it? Like I like to put an example of my life. I used to work in a company a few years back that they traces like metrics from the team health and so on, and I was doing a development to recreate a cache system, and whenever I start working on that part, I had to, because they didn't have automated tests and they didn't allow me to do it, I had to like test everything manually. So every time I change something, I had to somehow go and see the 31 different metrics and then see if something had break. But even if even if they haven't broke for any reason, that doesn't mean that the code is okay. So my suggestion here is like show them the pain. Is like much more faster, although they may get used to it because it's something that people get used to, and that's maybe the hard rock, at least from my side. I don't know, Matheus, if you want to add something.
Yeah, I think I can relate this question with like because it says the pain of creating or running. I could relate that with the test pyramid, for example, because if they are rejecting because it's a pain to create or to run, I would assume that you have like too many tests that relies on the top of the pyramid. Let's say you have like too many, like difficult to create or like some pains. So besides what Manu said, I would say that I would first like try to have a sneak peek on the how the testing strategy is, because if it's a pain, maybe as Kintback says, right? So if it's a pain, you should do more often and then find to uncover this pain and then fix it. So I will go for this one, and I think that's it. Yeah.
Thank you, Matheus. Good point. I haven't thought about that.
Yeah, Very good, Hans. Couldn't agree more. And yeah, unfortunately, the time is over. So we have half minute left. So I would like to take this opportunity and I would like to say a huge thanks, both of you. You did a great performance. I really enjoyed and we learned a lot, all of us. And of course, huge thanks to my helper and my other co-host, Oliver. And of course, to the audience, everyone who stayed up until here and everyone who joined to us today. It was a really important topic. Tests are really one of the most important parts of our application, right? They are the codified knowledge of our application. So yeah, again, thanks a lot, everyone. It was a pleasure, and I wish everyone a great morning, afternoon, and evening further. And we were Tech Excellence, learn how to deliver quality software faster. We have a Discord group. Don't forget, feel free to join us. So again, thank you, everyone, and see you next week.
Bye-bye.
Bye-bye.
Bye-bye.